how to find the residue of all the singularities of a function. So the function fz is singular where the denominator vanishes. So that's where sine z would equal 0. So z would equal n pi. It should be like a z like this where... So that means since sine z has simple poles at z equals n pi, and the numerator is analytic everywhere, the function fz has simple poles at each time it hits z equals n pi. Therefore, all singularities are simple poles. So let's compute. We've got the residue of z equals n pi of the function fz, where the limit is z to n pi. So it would be z minus n pi dot, and you multiply it to everything here. So I'll put that there, put the dot outside. So I'll just put fz. So remember it's cos z plus z cubed over sine z. So if sine z roughly equals minus 1 to the n, z minus n pi. This here feels like it might have come out of nowhere, but you should be familiar with the Taylor expansion of sine z about z equals n pi. And we know that the behavior of sine z near its zeros are a little bit of a tangent, but d dz sine z, where z equals n pi, would equal cos n pi, which equals minus 1 over n. So this is something to do with the Taylor series, but we've implemented it here really quickly. Probably should do another video on the Taylor series itself on how to get this, but if you are familiar with it, it should be quite straightforward. So therefore, the limit where z goes to n pi would be z minus n pi over sine z, which equals 1 over minus 1 to the n, which is minus 1 to the power of n. We're almost there. So the residue at, let's say, z when it goes to n pi, fz would be cos, we know that z is equal to n pi, so let's plug that in, n pi plus, we've got z here, n pi cubed multiplied by minus 1 to the power of n. But cos n pi equals minus 1 to the n. So therefore, the residue of z equals n pi, n pi, that's an n pi, that's pi, of fz would be minus 1n plus n pi all cubed multiplied by minus 1, dot n, which equals, now I'm going to simplify this out, minus 1 to the n dot minus 1 to the n plus minus 1 to the n dot n pi all cubed. Simplifying this out, we will get 1 plus minus 1 to the n pi all cubed. And there we go. We have used a bit of a residue theory to find all the singularities of this function.